Have you ever noticed that the word cyanide almost always comes with a sense of fear? Whether it's in detective stories, spy movies, or history books, cyanide has become almost synonymous with deadly poison. Just hearing its name is enough to make people uneasy. But is cyanide really just a mysterious substance designed to kill, or is there more to the story? The truth is, cyanide is far more common than most people realize. It's found naturally in certain plants, used in important industries, and even exists in tiny amounts within the natural world. So what exactly is cyanide? How does it become so dangerous? And why has this simple chemical earned such a notorious reputation throughout history? Today, we're uncovering the surprising science, history, and facts behind one of the world's most infamous compounds. Right here, on History of Simple Things. Although cyanide has likely existed for as long as life itself, scientists didn't identify it until the late 18th century. In 1782, Swedish chemist Carl Wilhelm Scheele isolated hydrogen cyanide while studying a pigment known as Prussian blue. Ironically, Scheele never realized just how dangerous the gas was, and historians believe repeated exposure to toxic chemicals, including cyanide, may have contributed to his early death. During the 19th century, cyanide compounds became valuable in mining and manufacturing because of their unique chemical properties. At the same time, their extreme toxicity became increasingly understood. Over the following centuries, cyanide gained a notorious reputation after being used in crimes, suicides, warfare, and infamous historical events. Yet despite this dark history, cyanide has remained an important industrial chemical that's still used around the world today under carefully controlled conditions. Despite what many people think, cyanide isn't just one chemical. It's actually a family of compounds that all contain a carbon atom bonded to a nitrogen atom, known as the cyanide group. This simple chemical bond gives cyanide its unique and sometimes deadly properties. Some forms, like hydrogen cyanide, are colorless gases. Others, such as sodium cyanide and potassium cyanide, are white crystalline solids that dissolve easily in water. Not every cyanide compound is equally dangerous, however. Some are relatively stable and far less toxic because they don't easily release free cyanide into the body. The danger depends on how easily a compound releases cyanide ions, which interfere with one of the body's most important biological processes. The frightening part about cyanide isn't that it destroys your lungs or heart directly. Instead, it attacks your cell's ability to use oxygen. Inside nearly every cell are tiny structures called mitochondria, often described as the cell's power plants. They use oxygen to produce the energy that keeps your organs functioning. Cyanide blocks a key enzyme inside the mitochondria known as cytochrome C oxidase. As a result, oxygen may still be flowing through your bloodstream, but your cells can no longer use it. It's almost like cutting the power lines to an entire city while the fuel supply is still full. The organs that need the most energy, especially the brain and heart, begin to fail first. Without rapid medical treatment, severe cyanide poisoning can become fatal within minutes. One surprising fact is that cyanide isn't purely a man-made poison. Nature produces it too. Several plants naturally contain chemicals called cyanogenic glycosides. When the plant tissue is crushed or chewed, these chemicals can release small amounts of cyanide. Bitter almonds, cassava, lima beans, bamboo shoots, and the pits of fruits like apricots, peaches, cherries, and apples all contain these natural compounds. Thankfully, eating a few apple seeds isn't usually dangerous because the seeds have tough coatings and contain only tiny amounts of cyanide-producing chemicals. Problems generally occur only if large quantities are crushed and consumed. Proper preparation is especially important for foods like cassava, which feeds millions of people worldwide but must be processed correctly to remove most of its naturally occurring cyanide compounds. Considering its reputation, you might wonder why anyone would continue using cyanide at all. The answer is that cyanide has some incredibly useful chemical properties. One of its biggest uses is in gold and silver mining. Cyanide solutions dissolve precious metals from crushed ore, making extraction far more efficient than many alternative methods. It's also used in the production of certain plastics, synthetic fibers, pharmaceuticals, dyes, and specialty chemicals. These industries operate under strict safety regulations because workers are trained to handle cyanide carefully, using protective equipment and controlled environments to minimize risk. While safer alternatives continue to be developed for some applications, cyanide remains difficult to replace in several industrial processes because of its effectiveness. Although cyanide poisoning is a medical emergency, it isn't always a death sentence. The first priority is removing the person from the source of exposure and providing oxygen and emergency medical care as quickly as possible. Hospitals can administer specialized antidotes that either bind to cyanide or help the body convert it into a much less toxic substance called thiocyanate, which is then eliminated through the kidneys. Because cyanide acts so rapidly, early recognition and immediate treatment make an enormous difference. This is one reason emergency responders receive specific training for handling suspected cyanide exposures. Cyanide has earned its fearsome reputation for good reason. It's one of the fastest-acting poisons known because it prevents the body's cells from using oxygen. But the full story is far more interesting than its appearance in crime novels and movies. Cyanide exists naturally in certain plants, plays an important role in modern industry, and has helped shape mining, manufacturing, and scientific research for more than 2 centuries. It's a powerful reminder that many chemicals aren't simply good or bad. Their impact depends on how they're understood and handled. And now you know the fascinating story behind one of history's most infamous compounds. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.
Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.